Okay, let's review some of the concepts that we just have learned, and let's do a couple of problem sets. So the first problem set is very simple. We have a simple game that you see here in table 1. We have two players. Player 1 can either play up or down, and player 2 can play either left or right. So before we answer those questions, let's just play the game. That's always a good strategy. So if player 1 thinks that player 2 plays left, shall player 1 play up or down? So we compare the 3 to the 2. 3 is better than 2, we underscore the 3. Then if player 1 thinks that player 2 plays right, shall player 1 play up or down? So we compare the 2 to the 0. 2 is better than 0, so we underscore the 2. So now we can already tell that up is a dominant strategy. Now let's turn to player 2. If player 2 thinks player 1 plays up, shall player 2 play left or right? So now we have to compare the 2 to the 1. 2 is better than 1. We underscore 2 for left. And if player 2 thinks player 1 plays down, shall player 2 play left and get 1 or right and get 0.05? So 1 is better than 0.05. So player 2 has also a dominant strategy, which is left. So we have up as a dominant strategy and left as a dominant strategy. And we have a Nash equilibrium, which is player 1 plays up and player 2 plays left, because both payoffs are underscored. So now answering the questions should be very quick. So for player 1, strategy down strictly dominates strategy up. No, because strategy up strictly dominates down. So B, strategy up strictly dominates down. That is correct. So let's highlight that. For question 2, for player 2, strategy right strictly dominates strategy left. No, it is also strategy left that strictly dominates strategy right. So let's highlight this. The Nash equilibrium of the game is up for player 1 and left for player 2. That is what we got. So A is correct. And the last question, which statement is true about the game? The equilibrium is the social optimum. Okay, the game is not a prisoner's dilemma. C, answers A and B are correct. That is the correct answer. Why? Because the Nash equilibrium, which is up for player 1 and left for player 2, that has the highest aggregate payoff of 5. All the other payoffs are less. So that's 0.5. So, and whenever the Nash equilibrium has the highest payoff for the society or for the players, then we do not have a Nash equilibrium. A Nash equilibrium, again, is a situation where the Nash equilibrium is not the social optimum. So in this simple game, there's really no big concern about anything. The players find the best solution. And that is actually true for each player. Player 2 can, the best that player 2 can get is to get 2. The best that player 1 could get is 3. So that is like simply the best outcome. Okay, let's just stop here and then let's do the second problem set in the next video.